Okay. Now, like I said, I don't think this is going to be that hard. So let's go ahead and just, hopefully you labeled, everything on your paper. And then we can just go ahead. I don't care if you just write down the answers, but the symbolism is important. All right. So it says use a figure to name each of the following: a line containing X. A line containing X. What would we call that? Anybody else?
Line segment.
What?
Like X would be the one.
No, you're naming the figure, guys.
Line X.
XM,
Line, not YM, that's close.
XM,
Not X. Okay, so again, now let me explain since we're having some trouble here. All right, so there's two ways to name a line. All right, you can name a line, any 2 points determine a line. All right, so you can't name it line Y, you have to name it with 2 points. So the answer to question number 1 should be line YR. All right, so this is how you name it, line YR. All right, now notice those are capital letters. All right, I will be describing lines with capital letters. You can call it line M, but that would be italicized, all right, lowercase. All right, but we don't write that way anymore. Just listen. All right, so a line can be written with 2 points. The 2 points on that line are Y and R, and you could label it M. Now, some of you are saying, well, what about X? Yes, you could call it line XY. You could call it also line XR. The order in which you name the line, what letter goes first doesn't matter. All right, because it goes on indefinitely in both directions. All right, so you pick 2 points, not 3 points, 2 points, or you can use a lowercase italicized letter, all right, which we will not do, all right, or I will not do. All right, if you want to label it that way, that's fine. All right, everybody good with that now on naming a line? All right. Now we want a line containing point Z. So now everybody should be able to tell me that's just what? Line ZR or lowercase l. All right, that is correct. It has to be italicized. All right, and the reason it has to be italicized is because later we'll show you how they name sides of triangles with lowercase letters. Angles are uppercase letters. There's lots of rules that we're going to have to learn. All right, but it's really simple. Go.
Why is there like a dotted, like line?
Okay, so someone now is asking me a good question. Why is there a dotted line? Because they're drawing 3-dimensional figures in 2-dimensional space. Does that make sense?
Yeah.
So that line RZ goes through that plane. It intersects that plane at what point? R. All right, is Z on the plane? No, it's not. The dotted line just represents the piece that you can't see. Right?
Yeah.
Makes sense? All right. So again, I understand the problem. Some of you are better at, visual things. All right. Now, a plane containing points W and R. Now, believe it or not, it's capital italicized B. All right, capital italicized B. I'm not sure how you're supposed to do that. All right. So generally, instead of writing italicized, you must write 3 non-collinear points to describe a plane. Now, what does collinear mean, guys? Collating. Collinear. Collinear. Think about this. Co-line.
With lines.
Co-line.
Together.
The points that are on the same line. All right. Collinear means points that are on the same line. All right. If you're co-president with someone, that means you're president with them. All right, so collinear means lines or points that are on the same line. All right, that's all that means. All right, just like now, if I said, what's coplanar? What does coplanar mean? Points that are in the same plane. That's how simple it is. Collinear, points that are on the same line. Coplanar, points that are in the same plane. All right, so if you want to define a plane, you have to define a plane with 3 non-collinear points. Now, let me try to explain why, and this is kind of tricky. If I said the points X, Y, R, do X, Y, and R define a plane? The answer is no. A line is not a plane. Does everybody agree with that? A line is not a plane. Can a line be in a plane? Yes, but it doesn't define a plane. All right. So that's why you have to say 3 non-collinear points. Y, R, and W are 3 non-collinear points. Do those 3 points fit in that plane? Is there another plane that they can go through? No, there's only one plane that fits those 3 points. All right. Now, something really important in geometry, which I remember arguing with my teacher all the time because it didn't make any sense, is that there are 3 undefined terms in geometry. All right. And these are on most tests. All right. The 3 undefined terms in geometry are points, lines, and planes. All right. There is no definition for a point. There is no definition for a line. There is no definition of a plane. They are all just concepts. All right. For example, why is there no definition of a point? So let's look at the board. Does everybody agree that's a point? All right. Well, why is it a point? All right. Because now if I blow it up, it doesn't look like a point anymore. It looks like a dot or space, correct? So a point is just a location. All right. I can make it really small too. Does everybody agree with that? So I'm trying to make it so small you can't even what?
See.
But it's still what? It's still there. It still exists. All right. So I always was arguing at how are we doing geometry when we can't even define the things that we're talking about. All right. Same thing with a line. All right. If you draw a line, right, what makes that a line? All right. A collection of points is what I thought. All right. But we really can't define it because it's the same thing. All right. I can do what? Shrink it down. I can shrink it down. Does everybody agree with that? All right. I can shrink it down. I can make it bigger. I can make it smaller. It can have width. All right. So again, we just have to make some assumptions in geometry. And I don't really like to argue about things. These are things that you just have to accept as true. All right. These are things you have to accept that are true. Those things that you accept that are true are called postulates. All right. The things that you can prove are called theorems. All right. We will be dealing a lot with postulates. All right. We have to make some assumptions in order to get through geometry. All right. But definitely points and lines and planes. Think about that. What is the definition of a plane? All right. Bless you. And very soon you will be getting out into, hopefully when you go to college, you'll study more math where, does everybody agree we are in 3-dimensional space? Does everybody know what that is?
Yeah.
But there's a lot of people who believe that space is what? Flat. All right. It's really just 2-dimensional. All right. Because we are just so what? We think we're big, but in fact, we're what? We're really, really, really small. All right. So a lot of people think space is just flat. All right. And you can start to bend space and do all kinds of cool things. All of that's being discussed with math. All right. The whole universe. It's amazing what they're being able to discover now with the new telescope. All right. That's out there peering back into centuries and hundreds of billions of years, they think. All right. So again, there's lots of things in geometry that are weird that you just have to accept are true. All right. And points, lines, and planes are things that we use to prove everything else. And like I said, we can't argue. If I can't define point, line, and plane, pretty soon we'll be doing some proofs where we'll be using points and lines and planes, but we can't really even define them. All right. So we know it's true because you can look around. We have buildings. All right. All of the buildings that are built are proofs. All right. They know that it will stand when they build it. All right. But there are assumptions that are being made. All right. So when I say a plane is used with 3 non-collinear points, you have to write any 3 points that are not on the same line will define the plane. 3 points on the same line do not define a plane. So you can write down any combination of numbers or letters with W and R, except you cannot use, well, you can use any because W and R aren't on the same line. Does everybody agree with that? Does W and R form a line?
Yes.
Yes, of course it does. Any 2 points determine what?
One.
It's just not drawn. All right. It's not there in the figure, but if I want to, W and R could form a line. Does everybody agree with that? So any 3 non-collinear points determine a plane. All right. So for the answer for number 3, WR and what else? Y, WR and X. All right. Am I allowed to use the lowercase letters?
No.
No. All right.
Why not? Because there's the line itself.
That's the line itself. Thank you very much. The lowercase italicized letters are the definition or define the line.
So you know how like the writing lines you write like a little arrow above it?
Mm-hmm.
What would we write for that? Would we still write? Like how do we write plane? Do we just
Honestly, you just spell plane and then you do with the 3 letters.
Okay.
All right. That's actually a good question. I'm proud of you. First for everything. All right. Name the geometric term modeled by each object. What?
a line segment?
Yes, a tightrope would be considered a line segment. Remember, a line segment is just a piece of a line. All right. And it has 2 endpoints. The floor is obviously what? A plane. All right. All right. Now, what I want to do is I'm going to put it on pause here for a minute. Well, we don't have to. I don't think there's many. I printed out some graph paper for us just in case we need it. And there's just one problem here I noticed with plotting points. So we're just going to ask you to just sketch it in, okay? So when we sketch it in, we just come over here. You can make your own X and Y axis. All right, I'm not looking for detail because it's just a sketch. All right, so a line in a coordinate plane contains 0, -5. So if you're going to graph 0, -5, we can come down here and do 0, -5. And we'll label that A. And then 3, 1, I would go over 3 and up 1. And we can label that B. And now we have to label C that is not collinear with line AB. So what does not collinear mean? Yeah, not on that line. All right, not on that line. All right, so anywhere you can put it. I don't care. Put a dot and label it C. Okay, now we're going to try to draw plane Z contains line X, Y, and W. Lines X, Y intersect at V, and line X and W intersect at P. All right, so when you draw a plane, generally what you do is you draw a parallelogram. This is what they want. Okay.
Okay.
Then it says line X and Y intersect at V. All right, so now what you're going to do is you're just going to draw 2 lines. There we go. And they intersect at point V. So you put a dot, then you put V, and now we label them X. I try to do a little italicized just to make them happy. So that's line X and Y. They intersect at point V. Now it says X and W intersect at P. Now notice they didn't mention line W intersecting V, correct? So I wouldn't have them intersect. I would probably just make it what? Maybe parallel. All right. So I'm gonna call this W, thank you. So we're gonna call it W. And then we're gonna intersect it at point P.
Is X not a point?
What does it say it is?
Oh,
You with me on that? I know it's kind of confusing. That's why I don't really like the italicized, right? We're gonna name lines with 2 points for the most part. All right, anybody have any questions with that? All right, it's not hard. It's just a matter of learning the symbolism. All right, here we go. Refer to the figure over here. Okay, so this is kind of tricky because some kids, it's hard to see. So in that figure at the right, how many planes are there?
3, 4, 5, 6.
Yeah, all kinds of answers here, right?
Wait, no. Wait, 1.
There's a triangle, right? Do we see the two triangles are 2 different planes, correct? And that's a prism, right? So there's 3, 4, 5 walls is what I see. I like to call walls because then I can translate a wall into a what? Plane. All right, so I just count the number of walls. All right, that's the number of planes. Is everybody good with that? So how many planes are in the figure above or in the figure 5? Name 3 points that are collinear.
H, J, no, A.
Say it.
There's only 2 points.
I need 3 points that are collinear. Go.
A, H, and B.
A, H, and B is an answer. There's another 3 points that are,
B, J, and F.
yeah, B, J, and F. Right. What did I tell you coplanar meant? On the same plane. I just don't think that's a hard definition. All right, collinear and coplanar. For some reason, people have a hard time with that.
What is
What do you think it means?
not on the same one? Like,
What does collinear mean?
like on the same,
What does yeah, so what do you think coplanar means?
it's like the opposite, not the same.
It's the same prefix, right? Co-linear, same line. So what do you think coplanar means?
Same plane.
Same plane. That's the logic behind it. That's what I'm trying to tell you. All right. And I used to think co-president. All right. All right, come on. It's just really not that big of a deal. All right. So name 3 points that are, or I'm sorry, are points A, H, J, and D coplanar.
Yeah.
All right, now sometimes if you don't want to get tricked, what I like to do is I like to just kind of highlight them. So I'm looking at A, H, then J, and then where's D?
No, they're not.
D is over here, correct? So I don't think they're coplanar because now, again, do we agree 3 non-collinear points determine a plane? Everybody hearing me? 3 non-collinear. So if I'm looking at this, I would like everybody to see that A, H, and J form this plane. Do you agree with that? And I understand some of you guys, honestly, you can't see. It's training. I couldn't see either. So does everybody see we're talking about that wall on the right?
Yeah.
Is D on that wall?
Yes. No. It's on the other side of the. Oh, it's the.
D is this point over here. Right? It's a 3-dimensional object. That is correct. All right. D is the vertex of this triangle. So we agree with that now.
Yeah.
All right. So again, some of you have to practice more than others to see it properly. Some people do really well in the first test because they're visual. Some people don't do as well because they're not. You can get visual by practicing. Trust me. So they are coplanar or not coplanar. Which one?
No.
No, they are not coplanar because D is not on the same plane, right? Okay, so now let's look at B, D, and F.
Yes.
Are B, D, and F on the same line?
No.
So they're automatically what? Coplanar, right? So now here's what people don't understand. So look, if I said B, C, E, are those coplanar? Everybody says no, and everyone is what? Wrong.
Oh, because it's the line.
So listen to me. Now, again, I know it's kind of tricky, but please pay attention. Is the plane BCE drawn? No. But if I were to take this right here and draw from here to here and draw from here to here, are they on the same plane now? Yeah, right. You see, it's deceptive, right? So is BCE drawn as a plane? Is there a plane though with to connect those 3 points? Yes. Now, just put your hand down and listen. Is it possible to draw the plane AHJD? It's not possible. Does everybody agree with that? It would go through 3 of those points, but will never go through what? It will never go through 4. Is everybody with me? All right. Is CDE coplanar?
Yeah.
Yes. Is CDFE coplanar?
Yes.
Yes. Right? C, watch me. C, that's what I'm saying. C, D, F, E. Are those coplanar? Yeah. 3 points determine a plane. Can more than 3 points be in a plane?
Yeah.
Yes. Infinite number of points are in a plane. All right. You just have to look at the plane and see if it's in there or not. All right.
What an AHJD work? Because like, couldn't you draw it still?
You draw that and then show me.
It just looked like a diamond.
AHJ is this plane. AHJ is this plane. Is D in that plane?
Oh, because it's on the other side.
Is D in the plane?
No.
No, it's not. So it's not coplanar. Or it's not coplanar. What?
How would you know AHJ isn't just like a triangle plane?
So what's the difference if I draw this from here to here? Or the blue, the rectangle? Is there any difference in those 2 planes?
Yeah,
Why? What's different?
like the size and the shape.
Does the plane stop there? No. The plane goes on indefinitely.
Okay,
You see what I'm saying?
not really.
Well, because you're limiting the plane to just the blue. Is E, all right, so you have a good question. Is E in plane AHJ?
No,
Of course it is. Why? Because that plane goes on indefinitely. What do you mean, which direction? Here's the wall right here. Here's the front wall. If I shut that door over there, does that mean the wall's not on the other side? The wall is still on the other side. Right? This TV covers up the back wall. Do we agree? Is the back wall still there? Can you see the back wall? No, you can't see the back wall. Right? You're limiting your perspective by just what you can see. But this plane goes on indefinitely in all directions.
D that isn't because it's on different.
You still on that problem?
I'm trying to.
D, you's 100% correct. D is on a different plane. D is on this plane right here. It is on that plane also. D is in,
And also C, E, F, D.
all right. You good with that, Brooks, or not?
Yeah, I got it.
Yeah, it goes on indefinitely, just like this line right here. If I say point A is right here, and does that line stop right here and here?
No.
No. So if I put a point way over here, it's possible that that's on that line,
Yeah.
right? It just goes on indefinitely. All right, so hopefully now you understand those planes go on indefinitely. All right, so that was pretty good. All right, let's look at 12 real quick. All right. So Ursa Minor, or the Little Dipper, is a constellation made up of 7 stars in the northern sky, including the star Polaris. The diagram at the right shows the arrangement of the stars in the constellation. What geometric figures are modeled by the stars? Stop. What geometric figures are modeled by the stars?
A square and a line segment? Bruh. A square? Bruh. Not a square, rectangle.
Tell me.
Plane and a line segment.
Stop. I am a failure. Thank you very much, guys.
Wait, what?
The stars in the sky. You look up at a star and you say, wow, that looks like a what? That's a point. A square, really? A square. I look up in the sky every night and say, wow, look at those squares. Wow, look at those squares. Stop. Stars model points, not squares. All right. We look up in the sky, we see points. All right. Are they really points? Are they really giant?
They're guys.
Yes, they're really big. And they're really far away. Oh my goodness. I've got my hands full this year. All right, here we go. Are star 1, star 2, and star 3 collinear?
No.
No. All right. Are they in the same plane?
Yes.
Yes, they would be. All right. Are Polaris, star 2, and star 6 coplanar?
Yes. Yeah.
Yes. All right, because they are non. What?
That was Ava, that wasn't me. No.
Ava, they're non-collinear, therefore they are in the same plane. You have to write that down for some of you guys who are slow.
I already did write
If
it.
3 points are not on the same line, then they are in the same plane. Now, when you look out in the sky, obviously you can tell me that just because there are those 3 points, everybody agree how big or small they could be, right? That's why you're trying to understand there's not really a definition for a point. There's not really a definition for a plane.
What was B?
Are stars 1,
No.
2, and star 3 on the same line?
Anything's. No, because it's.
No, you're right.
Smile.
Right, it's smiles. There you go. I like your squares and your smiles today. All right. So let me see if there's anything else. I think you wore me out. All right, here we go. 13. All right, Ava, just to make sure I'm not crazy. All right, look at number 22. What would you call the tip of that pen? Okay, do not say a square. Wow, ball points. Imagine that. I know. That's why they could be a triangle. All right. All right, guys, I think you're good now. All right, that was a great first day. Yeah, your only homework is to finish 1 through 48.
Wait, what?
You're welcome. 1 through 48. Yeah.
Wait, yeah, like.